Welcome everyone to tonight's Ice Age Floods Institute Tualatin Historical Society's joint meeting. Tonight, I am very happy to introduce Dr. Scott Burns, and his topic tonight is Glaciers, Sculptors of the Swiss Alps. He taught in Switzerland. That's where he started out his career. And as many of you know, we've known him as professor at Portland State University for many years. Scott has been all over the world. So Scott, I'd like to turn it over to you.
Well, thank you very much, Sylvia. And so I'm going to put that on. So Sylvia, can everybody see my slideshow there, which says Glaciers, Sculptors of the Swiss Alps?
I do believe so. If not, people would have to put a note into the chat, but I think we are good.
Well, sounds good. I'm just going to move something up to the top. Good. We're good to go. So thank you very much. And thank you for the chance to talk a little bit about the Swiss Alps. As Sylvia mentioned, I started my teaching career in Switzerland. And I lived in the French-speaking part of the Swiss Alps from 1970 to 1975. And that's where I started teaching geology there. And I used to take my students on field trips all of the time. And in fact, at the end of my last year there, we did 45 different field trips. Now, some of them were biology related, some of them were geology related, because I was also teaching biology. I was a alpine ecologist. I knew every plant, every animal, every glacial landform, every rock that we had in the Alps, and every geological structure that you had. And so when I approached Rick and Sylvia, I said, you know, I got all these incredibly great PowerPoint presentations that I have done on the Alps. And so if this survives tonight and you want me to come back, I have another one on the origin of the Alps and the processes that are there and the geology and things like that. And then another one on the plant and animal adaptations that you have got in the Alps. But tonight what I want to do is talk a little bit about glaciers and, oops, I just pushed the wrong button. See if I can get there we go. Okay, so what I want to do is take you to one of the most famous set of mountains, the Jungfrau, the Eiger, and the Munch. And these are all what we call horns. So tonight I'm going to be showing you glaciers, and I'm going to all the different types of glaciers that you got in the Alps, and then the landforms that you have got. Because the most beautiful mountains in the world are the ones that have been sculpted and eroded away by the glaciers. And on the right-hand side, you've got the Jungfrau. On the left-hand side, the Eiger, and then in the middle, the Munch. The Munch is the monk, the Eiger is the ogre, and then the Jungfrau is the young maiden. And so the monk is trying to keep the ogre away from the young maiden that you've got. And you got the Swiss flag that is in front that you see right there. And so we're going to be bouncing around, showing you different types of U-shaped valleys that were carved by the glaciers. And then also the cirques, arêtes, and horns that are created. Here's an absolutely beautiful U-shaped valley that we have got there. This is probably one of the most famous U-shaped valleys carved by glaciers in the past. This is the Lauterbrunnen Valley with the highest waterfall in Europe, which is Staubach Falls, which is on the left-hand side. And just absolutely a beautiful place. Or the Andermatt Valley, where the Rhone River comes down through this and on its way to Geneva. Instead of being U-shaped, it's more catenary shape, as you can see here. And if I do another one on the physical environment, I'll talk about the trees that you have on the left-hand side over there. And then as you get higher up in the mountains, you see hanging glaciers, hanging valleys. These are U-shaped valleys that are feeding off into deeper U-shaped valleys that you have got. This is very, very close to Andermatt, the last photo that I showed you here, showing that you had a glacier there in the past. You don't have any glacier today, and then the stream is starting to get cut down there. Highest waterfall that you have in Europe, and that's Staubbach Falls, just above Lauterbrunnen. And you in the United States, the biggest waterfalls, the highest waterfalls, are all in glaciated U-shaped valleys, and 4 of the top 5 happen to be in Yosemite Valley. The 5th happens to be here in Oregon, Multnomah Falls. Now, a lot of these U-shaped valleys are filled up with water and great lakes, and this is right at the end of this lake is Interlaken, which is a fan and a glacial moraine that is there, and that U-shaped valley is filled up with an incredible lake that you have got there. Or this one that I always used to go over the top of. I lived off on the left-hand side in the back of that mountain over there, but this is Lake Geneva. And Lake Geneva is dammed up by a glacial moraine, and that's where Geneva is today. So U-shaped valley with lake in it. Here is another U-shaped valley coming down into a very, very large U-shaped valley. These are, back in those days, hang gliders. Everybody was in the hang gliding. They aren't quite as popular today. And sometimes these U-shaped valleys actually get filled up with water. Now, this particular one is of a fjord. There are no fjords that are found in Switzerland, but the lakes kind of have that shape and form like you've got right here. And then here is another one that we have got here. This is, I don't know how I got this in. This is New Zealand. This is a fjord that you find down in fjord, and that's Mitre Peak on the left-hand side. And so this is an artist's recreation of the hanging valleys, the U-shaped valleys from the smaller glaciers that feed into a nice big U-shaped valley with a waterfall that you have got there. And then here is another one of the lakes. This is up in the central part of the Alps that you have got. Whoops, we went back to New Zealand. Okay, so as you're walking in the Alps, you look at all the road cuts and the cuts that are in the hiking paths, and when you see mixtures of big boulders and cobbles and little gravels all in there, that Mother Nature is shouting out to you, that's till. That is the deposit of the sediment that has been picked up by the ice and then carried down valley and then eventually deposited. And so as you can see, a glacier is carrying rocks and boulders on the top, but also it is eroding at the bottom. And it picks up a lot of boulders and cobbles, etc., in the ice. And I'll show you some pictures of that in a second. When it melts, what happens is you have unsorted material like this, which is called till. And if it's shaped into a particular form, we call it a moraine, like a lateral moraine, which is on the sides of the valleys, or a terminal moraine, which is at the end of the valley, or a recessional moraine as the glacier goes back. And so here is a picture that I took under the Gorner Glacier, and you can see all of these rocks and boulders. Look at the big boulder on the right-hand side that fell out of the ice as it melted. It was picked up by that ice and then deposited down there. All of these rocks are just here. That actually is a little bedrock knob that is here, but it has been deposited out of it. This is pure ice right in front of us, and then the nice clear ice up on top. And when it melts, it comes down, and that's glacial till that you have down at the bottom. And when all of that ice is melted, then you get a deposit like this. This is a classic glacial moraine with big boulders and cobbles and sand and silt and clay all mixed in together. So that's Mother Nature shouting out to you that that is what you are looking at. This one actually is just outside of Yellowstone National Park, and you can see this hummocky, bumpy topography that makes up that particular area. Or as you're in the Alps and you're driving through the road cuts, and when you see all this unsorted material like you see on the left-hand side here, Mother Nature is shouting out to you that that's a moraine. And in this particular case, it's a lateral moraine to a glacier that used to go down in the valley just in front of us here. So as the glacier comes down the valley, the furthest place down the valley where it deposits, and then the ice will just keep melting and melting and dumps a big ridge there, that is what we call a terminal moraine. Then as it recedes back, then you'll have recessional moraines like you see here. And so here is one of my favorite, this is the Morteratsch Glacier in eastern Switzerland. And you can see beautiful lateral moraines on the left-hand side, the right-hand side, and then here is the glacier that is right in the middle. Now note that it is low angle. Low angle is telling you that it is a receding glacier. It's getting smaller and smaller every year. I'll show you an advancing glacier coming up in a little while. And then here is a much smaller Cirque area. The Cirque Glacier is to the left-hand side, and here are remnants of one of the moraines, and there's a big lateral moraine off in the left-hand side. Here is another lateral moraine, actually not coming from this valley, but coming from the Valley Glacier coming out there. Or this is the Tingly Glacier in eastern Switzerland. Beautiful, crisp lateral moraines here and on the other side, and then an older one you can see right down here in front, and then you can see the lateral moraines coming from the glacier, which is on the left-hand side there. And then we're looking up into a cirque, and we'll talk about this. This is carved out by a glacier. There is a glacier there. Ice is coming through, and then the last year's snow around the edge. And this is just all what we call ground moraine as the glacier has gone back and forth and back and forth. One of my most favorite places in Switzerland to take my students was just outside of the town of Sion. And so the valley in the front right there is the Rhone Valley. The Rhone Glacier is up to the right-hand side. We'll talk about that in a second. Nice big U-shaped valley. Now this used to be a U-shaped valley, but then it was filled in with moraines. And each of these lighter colored areas here are lateral moraines that have been cut and now by a stream. So they're V-shaped valley here, cutting into an old U-shaped valley that has one lateral moraine here. There's another lateral moraine here, another one going across to the other side, and there's one way down below that had been eroded away. But when I turn to the right, where I take that picture, then you see the lateral moraine that has been eroded away. And what happens is you have big boulders that are on the top. And those are what the geological term is hoodoo. And we actually have a ski area in Oregon called Hoodoo because they have these eroded away glacial moraines with these big boulders that are on the top. And you can see that it's all glacial moraine. This is just all unsorted material. It's all limestone, so it kind of sets up just almost like a concrete. This is my favorite one that I take here in this valley with these large boulders at the top, and they retard the erosion underneath of it. And then so it all erodes away, and eventually they will just fall down. And as the boulders down here off of these pyramids, as they are called, the Swiss pyramids, have fallen off in the past. And another one just from the side. I was back just a few years ago, and this one that is right in the middle had fallen off. And so when two glaciers come together, what will happen is there will be a rockfall at that area, and there will be on the surface, there will be a deposit of sediment that we call a medial moraine. And so I will show you some examples. This is up very close to the Matterhorn. This is the highest peak that we have in Switzerland right here in the front. The Matterhorn is in back of us. And you can see where a glacier is coming together on the left-hand side and the right-hand side. This is the Gorner Glacier that you have got here. And where it comes together, there's going to be rockfall. And the rockfall goes onto the top of the glacier and creating a medial moraine. And you can see this medial moraine on the right-hand side is created by this rockfall that is up the valley here. And then you can see this medial moraine here. Where was it? It comes where these two glaciers came together up there. And we're looking down here. Now look at the color of that water down there in that Cirque. It is turquoise, greenish color, and I'll come back to that in a second. But this is where the rockfall is onto the surface. And then when we go out onto the glacier, and so this is in the zone of ablation where the snow has melted off from the year before, we go up to the medial moraine that is there, and we dig in, and there's the ice right beneath it. So it is not a very, very thick deposit. When all that glacier melts, there will be no landform there. There will be nothing like a lateral moraine or a terminal moraine. Sometimes the boulders that are carried by the glacier are different than the bedrock down below it, and that's what we call an erratic. And here is one very, very close to the Matterhorn, where I was a guide there for many, many years. Here is out actually in northern Switzerland, where the glaciers went out of the mountains. And the bedrock underneath is primarily granite, but then this particular rock is a limestone out of the Alps. And then as you get out of the mountains, as the glaciers kind of melted in place, you had a lot of big, huge ice pieces there, creating a whole bunch of small little lakes that we call kettle lakes. Not in the mountains, but this is out, especially to the northern side of the Alps. And then now and then, here is a cirque. Well, this is an area that has been eroded away by a glacier. There will be a huge rockfall deposit coming out, and that's what we call a rock glacier. And these are not as common in the Swiss Alps as you have in the Rockies or in the Cascades, but they are found there. Look at this one here. You can just see. And what has happened is, if we go back to this, a rockfall has come down onto an old glacier that is just about ready to run out of gas, and it continues to move down slowly, and so therefore you can see the crescent-shaped rock debris on the top of this. That's what we call a rock glacier. Here is where I used to take my students who were climbing up this, and if we dug in here, it was all ice on the inside. So it is a rock-covered old glacier there that we have got there. I'm going to go up to Alaska because sometimes glaciers surge. And what happens is a glacier all of a sudden will just take off and slide because there's a huge amount of water in the system. So all glaciers have huge numbers of caves that are inside. But then what happens is if the snout of the glacier, the toe of the glacier gets stuck, the water in the back will build up and up and up, and then what will happen is it'll cause it to slide on its base as the water comes out, and then it will surge at a much faster velocity. Last summer up in August when we were up in Alaska, we got to see a glacier that was surging. And instead of moving maybe 6 or 10 inches a day, it's moving 6 or 10 feet a day. And you can see then it kind of spreads out as the water moves out of it. This happened back in 1986, October 8th, when the Hubbard Glacier surged. It's a very, very large valley glacier that you have got coming down, and then it dammed up Russell Fjord just next to Yakutat Bay, and the water levels at the back of it just kept on going up and up and trapped all the whales and dolphins and other mammals in it, and they didn't do very well in fresh water. And this is what it looked like, and eventually what happened, it broke, and all of that water surged out, and all of the whales and dolphins escaped. And also the houses that were built right on the water escaped from being flooded out. I also wanted to mention just Pluvia Lakes, and there aren't too many in the Alps, but we have a few in the western half of the United States in the Basin and Range province. And when we had all of the glacial deposits and the glaciers in the west in the last 2.8 million years, we had a lot more rainfall. And all that water ended up in the valleys, and we had huge lakes that were there. The biggest one was Lake Bonneville. Went from where Salt Lake City is all the way up to the Idaho border, all over to the Nevada border. And then the remnants of it is the Great Salt Lake today. Now, let's go back to Europe. And so during the glacial periods, you had huge continental glaciers coming down. The spreading centers and the thickest ice was up at the northern part of Norway, Finland, and Sweden. And the glaciers came down all the way to the British Isles, down through northern Germany. The same thing in North America, starting out in the Hudson's Bay and coming all the way down into Wisconsin and Nebraska and Montana and Minnesota and Montana and Washington. But in the Swiss Alps, they had their own glaciers. And there was an area in between the Swiss Alps and the Arctic glaciers where a lot of the plants that grew in the alpine zone, the land above the trees, went to during the glacial period. And then when the glaciers melted, they went back into the high mountains. So for the last 2.8 million years, the temperature has gone warm, cold, warm, cold. Or I should say, here is warm, there is cold, and those are advances and retreats, advances, retreat of the glaciers in the past. We originally thought there were 4 major advances, 4 retreats. In the United States, we had the Nebraska and the Kansas and the Illinois and the Wisconsin. And in the Alps, you had the Gunst, the Mindel, the Vis, and the Verb. But now we have, based on sediments that have come out of the deep sea, we know that we had many fluctuations of the glaciers getting bigger and smaller during that period of time. And then this is what we are now seeing going way back over 300,000 years. Now, as you are in the Alps, you're on the glacier. We're on the upper Aletsch Glacier, and we look up on the edge. You can see that there is a line of gravels and cobbles and then bedrock here, and then very, very dark rock. That is all lichen covered. And that's where the glaciers were 600 years ago. That was what we call the Little Ice Age. It was a major advance. And then the glaciers have been melting ever since that time, exposing all of the bedrock and then the lateral moraines on the side since that time. So let's go back to the Rhone Glacier. This was the glacier. This was back in the mid-1800s. You can see right here, glacier coming out and coming into the Rhone Valley. If we went in back of us here, you would go all the way down to Martigny, Sion, Sierre, Aigle, and then Lausanne, and then Geneva. And then this is what it looked like at the turn of the century. There is the Rhone Glacier here. This is like 1830 when Louis Agassiz actually studied, and he put a chain of sticks across the glacier. And then he came back the next year, and they noted not only had they moved down the valley where the ice was thickest, they had moved the furthest. And he came up with the idea that glaciers are moving. And this was on the Rhone Glacier that you see here. There is the real glacier that is over there. I'm not going to talk about that. I just wanted to throw what I spent a whole summer in 1973 when I was teaching in Switzerland. And I spent it on the Juneau ice field up in Alaska. And we had different camps all the way across the ice field. And geologists in their spare time really do some weird things, and we always had to have an outhouse for every one of our permanent camps that we had on the ice field. And so instead of just having a one-hole outhouse, we had a 2-story outhouse that could be used simultaneously. And then if we had looked on the other side, there is a big picture window, so you could actually use the toilet and look out over the glacier. And enjoy it. This is one that actually I built. You can see it's barely holding on. And this is right below Cathedral Peak. And so we called this the Pew with a View. And then, so here is a beautiful U-shaped valley. Look at all the medial moraines that are coming down here that you've got. So now we're back to the Jungfrau, the Eiger, and the Munch. All horns that were created. Let's talk a little bit about some of the landforms that are created when glaciers eat away at the bedrock that you have got. So here is an ice field. This is actually the Juneau ice field where I studied up in Alaska in 1973. So all the valleys are filled up with glaciers. And then here is a peak sticking out. That is a horn. Here is a ret. That is a ridge that is carved by the glaciers, and you can see other horns that are off in the distance. This is what Switzerland looked like in the glacial period, the height of the glacial period when all the valleys were filled in. And this is the group that I spent in Alaska on the Juneau ice field. There's a picture of me at the end of 7 weeks after living on the glaciers. Here's a picture of the first day on the glaciers as they threw us into a crevasse, and then we had to learn how to get out ourselves. That's the last day as I hiked off with my crampons, 1973. And it's a retreating glacier, as you can see, very, very low angle. So here is the Rhone Glacier. This is where I used to take my students in Switzerland. And this is the Swiss postal bus. We would stop here, and then we go out and hike onto the glacier. And this is where Louis Agassiz actually came up with the idea of glaciers are moving. So let me talk a little bit about different types of glaciers. Continental glaciers. Here is the Greenland. That is a continental glacier, a very, very large one. Here is a picture of Greenland and that. Then we have valley glaciers. And so here is the Gorner Glacier coming off of Gorner Grat up here in Switzerland. Very, very low angle. And that's typical of a glacier that is retreating. Less mass is coming in the wintertime than is going out in the summertime as it melts. And this is the upper part of the Gorner Glacier here with the beautiful medial moraines that you have got there. This is over in eastern Switzerland. Beautiful lateral moraine on the right-hand side and on the left-hand side. And you're wondering, say, oh, look at these pine trees. They're all dying. No, they are large pine trees. Larix decidua, they're the only pine tree that actually loses its needles every winter. And so you can get brilliant photos in the Alps of these large pine trees with the glaciers off in the distance in the fall. I used to take my students every year on a hike here. This is the longest glacier in the Swiss Alps. This is the Aletsch Glacier. And these are some of my students that are out here, beautiful medial moraines that are on top of the glaciers. And then off in the distance, these are what we call Serp Glaciers. Those are small glaciers that are eating into the bedrock that you've got here. And then the area in between two Cirques is an arête. And here's another arête, and here's another arête, and another arête, another arête, and then Cirque Glacier, oops. Cirque Glacier, Cirque Glacier, Cirque Glacier, Cirque Glacier, Cirque Glacier. In the old days, they flowed right down into the Valley Glacier. Now the Valley Glacier is disconnected with all of them. And then this is all, you can see this is a little small Cirque Glacier here. The ice is showing through, and there's the snow from the previous year. And then there's a little Cirque down here, a little moraine, a terminal moraine for that glacier there, and another little glacier over in that Cirque. And then this is an interesting one. This is just below Zermatt. And this is all ice here, and then this is the upper part of the glacier. This is the snow-covered part in the upper part. This is not in Switzerland. This is actually Wrangell St. Elias National Park. These are all medial moraines produced by two major valley glaciers coming together. Tidewater glaciers, not going to be found in Switzerland. These actually are where the water goes into the sea and then floats and calves off. So how is a glacier created? Snow falls, and then it goes through metamorphosis in the snow. And what happens is you get melting at the end of the snowflakes, and they keep going, getting smaller and smaller and smaller until they are down into the size of what we call graupel or firn, F-I-R-N. Then eventually firn gets squeezed together, and that forms ice that you have got. So on a glacier, you will have the zone of accumulation and the zone of ablation or wastage, the lower part. And then there will always be a line at the end of the season where you'll have last year's snow up here and then ice sticking out. That's the lower elevation. And so every year what we do is we see where is the snow line and then where is the snout. And if the glacier is receding, that is telling you it is warming, the climate is warming. The snout will move up valley, up this way from one year to the next, and so will the snow line at the end of the season. So here is a glacier coming out of the mountains and then feeding down below. Now, here is a glacier that I used to take my students to every year. It's right on the edge of Mont Blanc, and it is an advancing glacier, the Trient Glacier, T-R-I-E-N-T, and very, very steep at the front. Let's see if we can see any of my students. There are two of my students right down here, and it is like 50 feet high at the front of the glacier. And that shows you that it is still advancing. Now, I went and visited this a few years ago, and it is very, very low angle. I mean, it is receding. And in fact, the end of the glacier is way up in here today. But when you look at a glacier, you can say it is moving downstream. It is positive mass balance. It is advancing when you have a steep front. But now, like most of the glaciers in the world are receding because the climate is getting so warm. This is the Garner Glacier. The toe of it, and look at low angle, you can just walk right up onto the glacier, and that's typical of a glacier that is receding. And then here, now when we look at a glacier, here is your snow line. Here is the end of the glacier. This is all ice that is here. This is still snow from the year before. And so at the end of the season, if we want to know, is it a positive or negative mass balance, we look at the difference between the snout, and where it was the year before, and then the equilibrium line. So when I did all my glacier work, this is how we got around. We were pulled by thiokol on sleds. And that is a picture back in 1973. This is how we got from one camp on the Juneau ice field to another. And we would dig snow pits. And the reason we would do that is to figure out how much snow had come in the preceding year, and was it a healthy glacier or not. Sometimes you could see actual differences in the snowfalls and the storms that you have, and some of the dirt and the dust that is in between them. Now, when we were on the glacier, you've all heard the story about don't eat yellow snow. But then you also, at the end of the season, saw a lot of red snow. And you don't want to eat red snow either, because that actually is an algae. It's actually a green algae that has a red color. And it is called watermelon snow. And when you take a whole handful of it and smell it, it smells exactly like watermelon. And a lot of people will say, wow, this is watermelon snow. You might want to taste it. Well, don't, unless you have constipation, because it will clean you out. It is quite interesting, but these are some of the last remnants of the last glacial period, small one-celled organisms that are living on top of the glacier. And as you go hiking across the glacier, you don't have to carry water with you, because there's always water that is flowing on the top of the glacier. Because these are temperate glaciers as compared to the North and the South Pole, which are frozen to their bed. And as you go walking across, it's crunchy, crunchy, crunchy. It's not like walking on an ice skating rink. It's fairly easy to walk. But if you were in an area with a lot of crevasses, you would wear your crampons. And this is my field assistant, Howie Langefeld, who is doing that here. Now here's Howie doing something we should never have done, because this is water going into a moulin, a glacial moraine, mill as they are called, and that's the beginning of a large plumbing system in the glacier. Because if he fell into that, he would be dead. We'd never find him. I would have been fired as a result of that. Now in Switzerland, if you go to Lucerne, they have a place called the Glacier Garden. And it's all in limestone. And they have these huge areas that were carved out at the base of these moulins, where all the water is coming in. If a large boulder falls in, it will grind around in the bedrock, especially if it's granitic. And when you have limestone, it will create like this. This is also in the Glacier Garden area of Lucerne. And very, very beautiful area. And so if you go to Lucerne, be sure to go see the Glacier Garden. If you get a chance to go underneath the glacier, the beauty of the light being bent to the blue end of the spectrum is absolutely spectacular. And so that's why it's so gorgeous underneath the glacier. Here's one of my friends, Monty Wilson, underneath. And here is the difference between ice up here and then the dirty ice down here. The glacier has picked up all of this sand, silt, and clay, and gravel and cobble at the bottom through a process we call plucking. And there's a lot of melting at the bottom of the glacier, and then the water will form around a rock, and then it will freeze. And then as the glacier is moving, it will just rip that boulder or cobble or gravel piece out, and that will become part of the ice system afterwards. Now, here are a couple of my field assistants, and we have been on the glaciers for a while, and this is the front of the glacier. And you can see there's a glacial lake that is out here. And you got to be careful, because, and we told Nancy over here, do not go down into here. You only walk from boulder to boulder to boulder. Take your crampons off, because you don't know what's out there, because the water table out there is very, very high, and you might sink in. Nancy didn't listen to us. And look what happened to her. She sunk into her hips And we said, we told you so. Do not do that. But she didn't listen. But walking across the glaciers by the medial moraines, always lots of fun. And you can see the top of this glacier is very, very dirty. And you can see we're going from one glacier to the next to the next. Now, when you put a lot of ice on the land, what happens? It will put a lot of weight on the crust of the earth, and the crust will go down. But then when you melt all of that ice and all that water goes back out into the ocean, what will happen is the whole ground will slowly work its way back up. It's what we call isostatic rebound. And that happened in Europe. And so you had the thickest ice from the continental glaciers up where Sweden and Finland come together. That whole area has lifted 100 meters out of the ground since the glaciers all melted about 5,000 years ago. And then the same thing in the Swiss Alps. Everything is rising up, not quite to the extent as you got here, because the ice was much thicker there. And in North America, the same way, around Hudson's Bay, where the ice was thicker, you get up to 100 meters or 300 feet of land coming out of the surface. Now, I showed you before that there is the upper part of the glacier, and the lower part. The lower part is a zone of ablation. The upper part is the land above the equilibrium line. Well, this is a ski resort that I got a chance to ski at, actually in the French Alps across the border. And you can see the upper part of the glacier still has snow. The lower part, all the snow has melted, and it's still the ski season. And they're skiing on the ice from the year before. So it was not a very well planned ski resort, because they are skiing on the zone of ablation, not a very, very good place. If you ever get a chance to go to the upper part of the Aletsch Glacier, they have caves that they've carved into the ice up there. It's called Top of the World, and it is a fun place to go to. And this is one of the times that I was in one of those. They had carved ice statues of Eskimos and then igloos up inside of those places. Now, this is an interesting glacier just below Zermatt. Zermatt is to the left in the Matterhorn. This is the Rhonda Glacier, R-A-N-D-A. And periodically, big crevasses would open up at the end of the glacier, and the whole end of the glacier would fall off and come down. You'll notice that there are no houses, no chalets built down in this area, because about every 100, 150 years, whole glacier breaks off and wipes out the valley. People knew about that, and so they built the whole town of Rhonda up to the left or to the right, not in this area. So glaciers can actually break off and come tumbling down. But traveling across the glaciers is absolutely a wonderful area. Let's talk a little bit about erosion. And so as a glacier goes over a bedrock surface, it will carry rock fragments in the bottom. It will smooth them all down. And then, but on this side over here, you will have a cavity, and there will be melting and freezing and melting and freezing of the water, and it will pluck out all of the rock surfaces here. And so plucking occurs here, abrasion here, and when you get that, that is what we will call a roche moutonné. It's a good French term. Roche means rock, and moutonné is actually a wig that judges would used to wear in Europe, the white wigs. Because it looked like a sheep, moutonné, and so this was a rock wig, and so you would see those as you're going up there. Not too many drumlins in the Alps, so we won't talk about that. But as the glaciers go over rocks, they'll smooth them down, they'll create striations, and then they will create little gouges, crescentic gouges and lunate furrows, and it will show you the direction that the rock is moving. Here is the Matterhorn. You can see the striations coming in this direction, showing us that the glaciers moved from higher elevation to lower elevation, and then created these crescentic gouges and lunate furrows. That's generally where there was a crack in the rock, and then the glacier would carry at the bottom. It would carry a whole bunch of rocks there, and they would get in that crack and then chip it out. For you can see there. One of my favorite places in the part of the Alps, this is an area very few people go to. This is up right where the Bernese Oberland meets the uh, meets the Pennine Alps, the highest ones. And you can see, look at all the Cirque Glaciers, Cirque Glacier, Cirque Glacier, Cirque Glacier. Then you have a big valley glacier with all the medial moraines. Look at the color of the water coming out of that. Because it is loaded with rock flour. Through abrasion, a lot of silt-sized particles get into the water, will bend the light to the green end of the spectrum, the bluish, greenish, turquoise end of the spectrum, and you can always tell when you see color like this that it is being fed by glaciers. This is on the Italian-Swiss border. Nice glaciers here. Look at the color of that lake that is there. It's all filled with this rock flour, bending the light to the bluish, greenish end of the spectrum. And as you go walking into the mountains, and you'll have two streams coming together. You see the one on the left-hand side, that's coming out of a spring. But the one on the right is coming out of a glacier, and it has all of that rock flour that is in that. And so when you have got these glaciers filling these V-shaped valleys that were originally had streams there, and then you erode them away, they will have U-shaped valleys, and they will form cirques. Cirques are these areas like you see here, here, and here. Those are the upper areas of a U-shaped valley. And then where two or three more glaciers have carved into a mountain, they create a horn, as you can see here on the left-hand side. And then where you have two glaciers carving in from either side, they will form an arête in between them. And then where there's a dip in the arête, that is going to be called a col. And you start out with V-shaped valleys, then you fill them with glaciers, creating all these cirques, and then you will have cirque, 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 U-shaped valleys, arêtes, and horns that you can see here. Those are the beautiful areas. Here's a classic example up here on the very, very top of a cirque with a little horn off on the right-hand side. Or another U-shaped valley here that you've got here. Beautiful U-shaped cirque that you see here with a nice arête up in the distance. Or here, beautiful U-shaped valley that is here. And then here's the Wildstrubel, the Steghorn, and the Tierhorny, and the Pfitzer over here. These are all horns too. Nice U-shaped valley that you see here. Beautiful arête in front of you right here. And then look at this arête. The guy's camping right here on this particular one. This is high in the Pennine Alps. But the ultimate horn in the whole world, the most beautiful mountain in the whole world, is the Matterhorn. And I love, when I was there, I would teach for 9 months, and then in the summertime, I would be a tour guide. And many days, the groups would have me take them up to the base of the Matterhorn, and then I would walk them down into Zermatt at the bottom and pointing out every plant and every animal dropping that was there. And then the most amazing horn in the world, on the Matterhorn, and how they climbed it, etc. And here's another picture of the Matterhorn off in the distance there too, and showing you for the third time the Jungfrau, the Eiger, and the Munch, three classic horns that you have got. So that is the story of the Swiss Alps. So hopefully a few of you have a couple questions. I tried to talk about these moving masses of ice in the past. They're still there today. Today you can see some incredible glaciers, especially the Aletsch Glacier. But wherever you go, the beauty of the Alps is there because you've had the glaciers in the past and you have glaciers there today. So Rick and Sylvia, thank you for allowing me to talk a little bit about the Swiss Alps. And let's see if there's any questions that might be out there right now that maybe I could answer. Thanks a lot to all of you.
Oh, thank you, Dr. Burns. That was really just amazing. Wonderful. So we do have a question in the chat, and it says, where did the water come from to fill Lake Geneva?
So the water for Lake Geneva comes out of the Rhone River, and it goes all the way up the Rhone Valley to the Rhone Glacier. So the original water comes out of the Rhone Glacier and the melting of the Rhone Glacier, which is getting smaller and smaller every year. But the two major valleys on both sides of the Rhone are the Pennine Alps, which are the highest mountains and the highest change in the Alps. And on the left-hand side are the western side of the Bernese Oberland, second highest chain. And they have a lot of glaciers also in those areas, and those are always melting, and all that water is coming down into the Rhone Valley. And so it's coming from the melting of the snow and the ice in the Pennine Alps and in the Bernese Oberland. Good question.
All right, here's another one. Great speech, thanks. And what is the meaning of Matterhorn?
Oh, and so a matter is the upper. It's the land above the trees. It's the Alpine zone in German, and so matter is the upper. So it's the area above tree line, and horn is definitely means pointed mountain in German, and so it is the pointed mountain above tree line. In the Alps. So that is where you got the name. But all of these, all of the mountains have names, and like the Hörnlihorn and the, all of them have an adjective in front of the horn.
All right. What caused the glacier to melt in the past?
Well, the glaciers are melting every summer. In the wintertime, it's very, very cold. Summertime, very, very warm. And so especially the lower parts of the glaciers are going to be melting a lot in the summertime. And they do this every year. But you will get, as the whole climate is warming during that whole period of time, there you'll get more massive melting of the glaciers in the past. Now, before we go back to 2.8 million years ago, when all the glaciers and the Quaternary period in the Pleistocene started, we didn't have glaciers. And in fact, in the 30 million years ago, the Earth was much, much warmer than it is today. And it was only when Antarctica got moved to the South Pole and you had snow there all of the time, and therefore reflecting light off into the atmosphere, and therefore a net cooling, and the Isthmus of Panama formed between North and South America, and stopping a major current that went from the Central Pacific into the Atlantic, that you had a net cooling in the atmosphere. And so the glaciers have advanced and retreated for the last 2.8 million years. So that's a circuitous answer to that question.
How was the elevation measured for 5,000 years ago?
Oh, the elevations were all done through triangulation. And I don't know how they figured out the lowest elevations that they had. But then once you got an elevation, then you would triangulate and get higher and higher ones. Probably the elevations were figured out using atmospheric pressure, and they had very, very crude ways of measuring atmospheric pressure. As you go up, the atmospheric pressure decreases, and so that's possibly how. That's an instrumental thing. I'm just a dirt and rock guy, and so I don't know the real good answer to that.
All right. When did you take these photos?
I would venture to guess most of these photos are taken in the 1970s when I was living there, and we had a few from up in Alaska too. So most of them were during that period of time.
All right. So toward the end, the diagram, how do a cirque and a rock basin differ?
A rock basin is basically just another name for a cirque. Cirque is French, like circus, and that's circular. Arrête, arrêté, stop. That is also French. Horn is German, and so most of the terms that we have in glacial work is French, because Louis Agassiz was French-speaking geologist. But then also you had the German-speaking geologists in the Alps too, and so they're mostly German and French names that you've got.
Okay, great background there. Another comment, enjoyable presentation, a good glacial refresher for me. Thank you, Scott. And another, when was the highest level of glaciation? What is the dominant rock type?
All right, so the dominant rock type depends upon where you are in the Alps. In the Bernese Oberland, it's all limestone. you get over into the Pennine Alps, you get into more of the metamorphic rocks, and you get a lot of gneisses and schists and phyllites and stuff like that. And then you get the pre-Alps, the little mountains that, like where I lived, those were all limestone and shales that you have got there. And so, if Sylvia and Rick invite me back, so I talk about the origin of the Alps and all the different rock types and the processes, we will talk about that at that particular time. And the maximum advancement of the glaciers, where the glaciers were all the way down to Lake Geneva, and Geneva, which is on a glacial moraine at the end of the Rhone Glacier. And that was at about 21,000 years ago.
Wow. Wow. Well, those are the ones that we have in the chat. Does anyone else have a question for Scott? Just speak out.
Yes, Burgles, Scott, you got any plans to go back there?
Yes, now that COVID is slowly waning, but right now I'm giving this talk from Toronto. And so it's 11 o'clock, so it's time for me to go to bed, because tomorrow I fly to Portugal to give a talk on climate change and the increase of geodisasters like landslides to an international organization. International travel is awful right now. You have to get all these COVID tests, and every country has its own app to get in, and you have to have all these different things lined up, and you have to learn how to download those apps. Travel is not easy right now, and this has been the most mind-boggling trip so far, and I got a lot more. I have 8 more legs to do, or 7 more legs, so I will be back in the Alps next time I get a chance. I love it. I love it. It's so beautiful. And that was my home for 5 years. So absolutely wonderful place.
Wow. So another comment, thank you. Very enjoyable trip to Switzerland and to the 1970s. Another comment, would love to hear and see the rest of the speeches. Scott, we'll definitely have you back for those other talks. Thank you for your kind offer there. Then another question, wasn't Agassiz's theory of glaciers discredited until he moved to America?
You are right. Yeah, he did. He went to, I think he either taught at Harvard or Yale, no, at Harvard or MIT. Yeah, it's true. The local people just did not believe that he was true. But then the rest of the world started believing, and I think it's very obvious that they are moving. So that's good. So Rick and Sylvia, thank you very much for the invitation. I'm going to go to bed.
Yes.
And we'll see all of you back in Portland in a couple of weeks. And thanks again for turning out tonight. It was great to see a lot of you, and big hugs to everybody. And if you get a chance to go to Switzerland, do it. It's absolutely wonderful. All right, so we'll see you later. I'll sign off, and everybody have a good evening.
All right. Thank you very much, Scott. That ends our program for tonight, and we will see you hopefully next month. Thank you, everyone, for joining us. Good night.